In this video, we will learn how to solve two-step equations.
Let's start our first examples of solving two-step equations. These are equations that can be solved with two inverse operations. The steps that we're going to take are the following. First, we're going to find the location of our variable. Is it on the left side or the right side of the equal sign so that we can find the operations being applied to the variable and do inverse operations to undo them. Now, inverse operations are also known as doing the opposite. The order of doing inverse operations is the following. We first move anything that is being added or subtracted, and then anything that is being multiplied or divided. Now, the inverse operation of addition is subtraction. That means that we undo addition by subtracting. The same thing happens with subtraction. The opposite of subtraction is addition, the opposite of multiplication is division, and the opposite of division is multiplication. So let's start with our example 1. Our example 1 reads 6m minus 5 is equal to 3. The first thing we do is locate our variable, and in this case is on the left side. And we can see that the operations being applied are subtraction and multiplication. Because of the order of inverse operations, I'm first going to move this subtraction. The opposite of subtraction is addition, so I'm going to add 5 to both sides of my equation. From left to right, that's going to give me 6m. Now, negative 5 and positive 5, since they are different signs, we're going to subtract them. So 5 minus 5 will be 0. And on the right side, 3 plus 5 will equal to 8. Now, the next step is to continue to simplify. You see how here we have 6m plus 0? Well, if you had a number and you added 0, you get back just that number. So then if I have 6m and I add 0, I just get back 6m. On the right side, I still have the 8. The next thing is to undo or get rid of this multiplication. Remember, the way that we do that is by dividing. So I'm going to divide both sides of the equal sign by 6. Being very careful here, 6 divided by 6 is going to go to 1. So I get 1m. Do not get it confused with what we did above. And let me show you what I mean. When we were up here, we were subtracting. So that's why this went to 0. But down here we are dividing, so 6 divided by 6 goes to 1, not to 0, so be careful there. On the right side, if you notice, I have 8 divided by 6. Well, 8 cannot be divided by 6 evenly, but it can be simplified by 2. So I'm going to simplify this by 2. That means that the numerator, 8 divided by 2, will become a 4, and the denominator, 6 divided by 2, will become a 3. Now, we can continue to simplify even further. Right here for this one, if I have 1 times m, I just get back my m. So now I found the solution. M is equal to 4 over 3. Okay, let's try another example. Example 2 reads 2 is equal to negative y plus 17. Now, we have to be careful here for the following reason. So my variable is on the right side this time, and it has two operations being applied. It has addition, but it also has multiplication. Now, you might not be able to see the multiplication, but I'm going to show you the following. Now, in example 1, we had 1m, and we simplified that to m. The same way that we are allowed to go forward in this, we can also move back. So you can add a number 1 as a coefficient to your variable, and it will still mean the same thing. So right here on the y, I have this negative. I can put a 1. So by putting the 1, I can clearly see that this y is being multiplied by negative 1. So then I have addition and I have multiplication. So which one do we do first? Well, according to the order of inverse operations, we need to do the addition first. So we're going to subtract 17 from both sides of the equation. From left to right, 2 minus 17. Since they have different signs, we subtract and keep the sign of the largest. That will give us negative 15 equals, bring down that negative 1y, and then 17 minus 17, well, that goes to 0. So we place here a 0. Now, whenever you add a variable plus 0 or a number plus 0, remember, I just get back the negative 1y. Don't lose the equal sign and the left side. Remember, we still have to undo that multiplication. The opposite of multiplication will be to divide. So I'm going to divide both sides by negative 1. Okay? From left to right, 15 divided by 1 is 15. and the negative negative will make that 15 a positive. Don't lose the equal sign. Negative 1 divided by negative 1, that's going to go to 1. Remember, that doesn't go to 0. And then bring down your variable. Don't forget that multiplying a variable times 1 is just the variable. So then the solution for this will be y is equal to 15. Let's try one last one for this. Example 3 reads, x divided by 5 plus 7 is equal to negative 9. The location of my variable is the left side, and it has two operations being applied, addition, and then it has that division by 5. We move the addition first by subtracting both sides by negative 7 very carefully. From left to right, I have x divided by 5. 7 minus 7, that goes to 0. Don't lose the equal sign. And on the right side, you have negative 9 and negative 7. Because I have the same sign, I'm supposed to add and keep the sign. So then this becomes negative 16. Let's continue. Remember, when we add plus 0, we just get back what we were adding. Don't forget the equal sign and bring down the right side. Now we need to undo that division by 5. Now the opposite of division is multiplication. So I'm going to multiply both sides of the equation by 5. Now there is a property called the reciprocal of a non-zero number that states that if you multiply a variable or a number times its reciprocal, these two will get eliminated and the answer will be 1. So for us, these two are going to get eliminated and our answer will be 1. But then we have that x, so I have to bring it down. On the right side, I have negative 16 times 5. Well, 16 times 5 is 80, but because they're different signs, the answer will be negative. Don't forget that 1x is the same as just x. So my solution will be x is equal to negative 80.
Thank you so much for watching, and I'll see you in the next one.